Hello again, this is Mark Summers from Summers Technical Services. I'm going to do a quick review on fan performance curves in anticipation of doing our flow simulation in SOLIDWORKS. So this is the performance curve for a fan. We're using a Comar Rotron tube axial 12-volt DC fan. There's a model number from the manufacturer, and this is a part number that we purchased from Mouser, and the designation on the model number, turns out this B tells us that we've got this fan curve we're going to be using here, and that fan curve follows this green line here, and I'll trace over here. And so depending on the operating conditions of the fan, we'll be at some point on that fan curve. And so if we look at the manufacturer's brochure on this fan, it claims it's a 235 cubic feet per minute fan. And that's somewhat misleading in the fact that that only occurs when you're in this first situation we're showing in the bottom here, this first picture, where the fan is sitting on the table. It's got atmospheric pressure on the left and atmospheric pressure on the right. And you turn the fan on and it's going to operate at maximum flow rate, which according to this curve is going to be 235 CFM. So let's define these axes. So the x-axis on this curve is the volumetric flow rate, and the y-axis is the pressure difference between the inlet and the outlet of the fan. And so that is defined. We need to remember how we define pressure. Absolute pressure is the gauge pressure plus the atmospheric pressure. And so this pressure on this curve here is referring to the gauge pressure. Okay, so looking at this curve, this first picture is represented by the point at the far bottom right of the curve, which is the point down here at the bottom. And so when there's no back pressure, static pressure over here on the vertical axis, when there's zero static pressure, which is this zero right here, which is this first situation, the volumetric flow rate is right here, which is 235 cubic feet per minute. So that first picture is this point on the bottom of the curve. The picture at the bottom represents what happens at the other end of the curve. And so if I connect the same fan to an enclosure, a sealed enclosure, and the air has no way to escape, I'm going to have zero flow rate. The air is just going to have nowhere to go, so there's going to be zero flow rate. And so in that case, I'm on this top part of the curve, which is right here at this point. And in that case, it's indicating my flow rate is going to be 0 cubic feet per minute. And that back pressure is going to be 0.8 inches of water. And so I'm going to be operating somewhere between those two extremes. Either the air is going to be blowing freely through at 235 CFM, or if I mount it for some reason to a sealed box, I'm going to get no flow rate. And so we're going to be operating in between there, and that's what the flow simulation program is going to do. We're going to input this curve, this data from this curve, into SOLIDWORKS flow simulation, and it will figure out where I am on the curve as far as the back pressure, and then compute the correct flow rate, volumetric flow rate. So that's the next step in our process is to do the flow simulation, and so stay tuned for the next video where we show how that magic happens.